of matter that was related to say different states, and we studied one very important relationship that we have been quite familiar with now, that was PV is equal to nRT. Now from here we'll utilize this equation even for our cases wherever we know that our gas is an ideal gas. But in order to study the properties or the nature of the states of matter, how they interact, what we basically have is thermodynamics. As the name suggests, thermodynamics, what does it mean? There are two types of mechanisms that you can talk about. One is static process and the other can be a dynamic process. Static matlab ruka hua, okay, and dynamics matlab something which is in motion, right? And when I talk about thermo, that means it is related to some kind of a study which is related to my changes which are caused by the majorly because of temperature or maybe heat. So whatever properties that I'm going to relate to this will be basically my thermodynamics. So I can say that basically it is nothing but the study of energy transformations. Energy transformations matlab, say for example, when you operate a cell, you know that the chemical energy is being utilized to do some kind of work, right? The chemical energy may be converted to an electrical energy may be converted to a chemical energy, and things like that. Say when you burn a fuel, alright, to run an engine, say example can be, say you burn a fuel, alright, for running an engine, in an engine. So what kind of an energy transformation is this? You are utilizing the chemical energy because some fuel is getting burned, and you know that whenever your hydrocarbons, like for example, are burnt, what is the end product? You get carbon dioxide and water. So here in this case, what are you going to get? The chemical energy is getting converted to the mechanical energy because your engine is actually working, it's doing some kind of a mechanical work. So here you say that your chemical energy is getting converted to mechanical energy. It is very important that you understand the meaning of chemical thermodynamics first. You talk about any kind of an energy transformation, and that energy transformation is nothing but it is the conversion of one form of energy into another form of energy by some kind of thermal changes which may be related to some kind of movement. That means your process is not at all static. Okay, then one thing that we can relate here is you get the relationships. Remember that from here you get the relationships of heat and other forms of energies. So basically, whatever you can relate to the transformations of heat and its energy can be related to your thermodynamics. Now, why are we studying this? The main thing is that what we need to do here is to understand the objectives of thermodynamics. In the objectives of thermodynamics is like, now you understand that whenever we talk of any transformation of any process, transformation of energy, we are talking about the study of thermodynamics. Objectives, the very first purpose is, say I talk about any chemical reaction A giving B. How would I know whether that reaction will actually happen? You also know H2 plus O2 is existing here in the room as well, but it's not forming water. But how will I get to know at what stage will it be spontaneous or when the reaction will happen? That I will get to know from the study of thermodynamics, because the laws of thermodynamics which we will be doing will talk about the feasibility of any process. Feasibility of any process means whether the process is going to occur or not occur. Okay? So it will, and feasibility is also termed as spontaneity. I repeat, the purpose of doing chemical thermodynamics is simply, the very major purpose is like to know the feasibility of any process, whether the reaction is spontaneous or not. If it is spontaneous, then that means the process will occur. Okay? Or if I say if the process is feasible, that means I can easily carry on with that process. Then the next thing is that we can also find out the yield of the products. And then, of course, using the study of thermodynamics, I can arrive at many more relations. Say I can arrive at many more physical chemistry concepts. Like for example, your Raoult's law, etc. They all can be related to your thermodynamics. So by using the basic principles of thermodynamics and the laws of thermodynamics, what we can do is we can actually study very many other physical chemistry concepts. But then what are the limitations of chemical thermodynamics? The limitations are, it is talking about the feasibility of the process, but it is not talking about the path or the mechanism which is followed. So it is not talking about anything about the mechanism of the process as to how A is getting converted to B. It will only tell you कि A B में convert हो जाएगा या नहीं होगा. It will not tell you कि वो कैसे convert होगा. Got the point? So it will talk about only the feasibility of the process कि होगा या नहीं होगा. But it will not tell you anything about the mechanism which is followed. Okay? Then another thing that it will not tell you about is it will not tell you about the speed. अब मान लो A B में कन्वर्ट होने में 4 दिन लगाएगा या 4 घंटे या 4 मिनट, उसके बारे में it will give you no information. It will only tell you whether it will get converted finally or not, irrespective of the time taken. So chemical thermodynamics का ये limitation है that it will just not tell you about the rate or the speed at which your process is happening. Okay, and then another thing is that this is the study which deals with only macroscopic systems. It does not talk anything about the microscopic entities. Like earlier when you have done the study of microscopic entities, and what is that study called? Quantum mechanics, right? So whenever we study quantum mechanics, there we had studied that whatever properties your macroscopic systems have, they are possessed even by the microscopic entities. But when we talk about the laws of thermodynamics, they are only applicable to the macroscopic systems. So the limitation is that they cannot be used for the microscopic systems at all. Okay, they cannot be used for the microscopic systems. Then what we have is that basically you have to remember that these laws are now applicable only for what type of systems? Macroscopic. And another thing that you need to understand here is that we basically deal with thermodynamics, say in stages where we have some kind of an equilibrium which is set. Say from when one system is getting converted from one equilibrium state to say another state which is going to be at equilibrium. So when I talk about this is what we are now by and large going to do in your course, that is the study of thermodynamics which is dealing with energy transformations. अब energy भी बहुत type की होती है. Whatever energy transformation, any energy. We talk about internal energy, we talk about heat energy, we talk about electrical energy, we talk about gravitational energy. Any kind of energy transformation is generally what? Chemical thermodynamics. And when we say it's chemical thermodynamics, by and large we are relating it to the chemical processes. और chemical processes क्या होते हैं? Reactions. जो भी हम reactions करें वो chemical processes हैं. So by and large it is the relationship of heat energy with other forms of energy or any kind of transformation. Now next thing that I told you is that what are the objectives of thermodynamics that we need to understand? The objectives and by and large are it helps you in finding out the feasibility of the process. Feasibility का क्या मतलब होता है कि reaction होगा कि नहीं होगा. अगर वो होगा तो मैं कहूंगी reaction is spontaneous. Alright? Then after that, it will also talk about the yields of the products. Yield matlab कि finally how much amount of the product am I going to get? Okay, say supposedly I start with 100% A, maybe I may get 80% of B and the rest of the 20% is dissipated as heat energy. वो वेस्ट हो गया या फिर वो साइड प्रोडक्ट कुछ और बना रहा है या समथिंग. सो दैट इन्फॉर्मेशन ऑल्सो आई विल गेट फ्रॉम माई thermodynamics. And whatever laws I am going to do under my thermodynamics topic, those can be utilized to understand other topics as well. Okay. Then I talked about the limitations. The limitations by and large are that it will not talk about the rate or the speed at which my reaction is occurring. Okay, the science which deals with the speed of the reaction is chemical kinetics. This you will do next year. When you talk about the rate, that means you are talking about the kinetics of the reaction. Which you will do, I mean in 12th standard, it is very much there in your course, chemical kinetics. It talks about the speed of the reaction, alright? But